That is it. We are live with James Lamb and Adam Sroka. I feel like I have dyslexia when I pronounce your name.
I got it wrong for 18 years.
I want to put the K where the R is and say Skrora, but it's really Adam Sroka.
Polish word for magpie. That helps.
Oh, yeah, there we go.
Anyway, it's not about me.
There we go. So Adam's been filling in for Vishnu these last couple of weeks because we've been just filming a ton of episodes, and Vishnu actually has a job that he has to do stuff with, and so he's been having to do that, but Adam has been picking up the slack. And so I appreciate you being on here, and I appreciate our guest of honor, James. It is fascinating to hear your story. I know a lot about it because I have caught up with who you are and what you've contributed to. And you came on the hangout that we're on right now, and Adam also knew who you were. But I want to make sure that everybody else that is listening knows who you are. So can you give us a bit of background on what you've been up to in the machine learning space?
Sure, no problem. And thank you so much for having me. This is a lot of fun. It's a good way to start my morning. So yeah, my name's James Lamb. I'm based here in the south suburbs of Chicago, near Chicago's best airport, Midway Airport. So if you fly here, don't fly to O'Hare. I am working as a machine learning engineer at SpotHero. If you've never used SpotHero, SpotHero is an app for basically booking and selling parking spots. It's great. I'm going to be using it this weekend at the Patriots game, so it's a great thing. I also have been heavily involved with data science projects in the open source world. So I've been a maintainer on the LightGBM project for I think maybe 3.5 years. I'm not exactly sure. A couple of years now. I started in that project working on the R package, but sort of am touching every part of it now. Before this job at SpotHero, I was working at a company called Saturn Cloud, where we were making sort of like a managed data science workbench. Like there's like a bunch of those companies, right? That are like, we sell you you pay us money, we give you a URL to Jupyter Lab, and then run some other infrastructure for you. We were one of those. And at that company, I got really heavily involved in the Dask ecosystem. I haven't been as involved in it recently, but I did at least, work on moving some Dask, there was a Dask LightGBM project, for example. I worked on moving that, sort of upstreaming it into LightGBM, worked a little bit on Dask ML and some of the other sort of Dask community stuff. So I have been working as either a software engineer, machine learning engineer, or data scientist for 7 years now. I think it's fair to count the 2 years where I was working as like an economic analyst as data science work. I was, doing applied statistics with data and software to solve business problems. Sounds like data science to me. Happy to answer any more specific questions about that stuff.
Well, maybe can you just, for those who don't know what LightGBM is, can you dive into that a little bit?
Yeah, I'd be happy to. So LightGBM, GBM stands for Gradient Boosting Machine. LightGBM is a framework for doing supervised learning on sort of tabular data using gradient boosting and tree-based learners. So if you've ever heard of XGBoost or CatBoost, these are very similar projects. LightGBM came out of Microsoft research, and its sort of like big first innovation was this. And by the way, before I say this, I was not involved with the creation of LightGBM. I don't have a PhD in statistics. I was just willing to do the software engineering dirty work to help keep the project portable and usable, and et cetera, et cetera. So what I'm about to tell you, I'm not taking any credit for inventing. I could never have invented this. In tree-based supervised learning, right, one of the things that's really expensive is sort of at each stage of growing a tree, picking the next split. Right? A split is a combination of sort of a feature, like one of the features in your data, and a threshold, some way to divide the feature into two different buckets. And so each time you want to choose a split, you have to evaluate all of these different combinations of features and thresholds. And so the space of sort of how long it takes to grow one tree grows the more features you have and the more diverse their values are. The big innovation in LightGBM was to take continuous features and bucket them into histograms. To say, look, we don't necessarily need to care about, for say like something super continuously valued, right? Like the temperature outside measured to 3 decimal places. There's really not probably a big difference in explanatory power between it being 27.123 degrees and 27.125, right? So what LightGBM does is this pre-processing where it buckets continuous features into histograms. By default, I think 255 sort of histogram bins. And then the only split thresholds that are considered are the boundaries of the histogram. So like each little sort of slice of the distribution. This makes training a lot faster. It also makes the in-memory representation of the training data much smaller than your raw data. And so that allows for like distributed training where you use multiple machines to train a model because the amount, like the size of the information being exchanged is much smaller than the raw data. It allows for a lot of interesting things. So that's sort of LightGBM. You would use LightGBM on tabular data for sort of binary classification problems, multi-class classification problems, regression problems, and learning to rank problems. Learning to rank problems are sort of like if you're building a search engine or something like that.
Really good run through. Yeah, I think I first bumped into LightGBM about probably 2016 or 17 or something. And this was back in the day when XGBoost was winning everything in Kaggle. And so it was like, right, learn XGBoost because that's how you be a good data scientist, right? But and then try and do something different. And it was, yeah, sort of pitched to me at the time as it does something clever about bottom up versus top down as well compared to XGBoost. From what I remember, it's been a long time now, but
yeah.
No, go on.
Yeah, there's a couple other things.
Yeah.
LightGBM sort of comes with built-in support for categorical features and does some interesting things with them. For a long time, until very recent releases of XGBoost, you had to sort of encode your categorical features before presenting them to XGBoost, right? LightGBM, you basically just pass a parameter that says, these are the features to treat as categorical, and it will sort of do some interesting things. LightGBM has built-in support for bundling together features. So for creating sort of like interaction terms between features during pre-processing, LightGBM will handle sparse features through sort of that bundling mechanism. So it will say like, hey, if two features are sort of like when one is non-zero, the other is zero and vice versa, you could lose zero information by just like stacking them on top of each other, right? LightGBM will do that automatically. There's a lot of stuff there. I think though it's also like been really interesting working on this project to see sort of the social aspect of it. We have a pretty good relationship, the LightGBM maintainers, the XGBoost maintainers, and the XGBoost maintainers. We're sort of all internet friends, and if you look at LightGBM's structure software-wise, right, you look at like the way that the repo is set up, especially the way that the R and Python packages are laid out, they look exactly like XGBoost, right? That's not accidental. We have all sort of like borrowed ideas from each other. And in fact, you'll even see like, I'll give you another short example of that. One of the other sort of innovations that LightGBM had was something called leaf-wise tree growth, which was basically in other sort of tree-based machine learning algorithms, like most implementations of random forest, for example, the trees that are grown depth-wise, which means that basically if you think of like a tree going out like this, an entire row of the tree, if you want to say that, like entire layer of depth had to be filled out before a new node could be added further down, right? LightGBM said, well, that doesn't make any sense, right? Like what if your first split splits like 75% of the data to one side? You might want to keep explaining that data, right? So LightGBM will tend to grow these like, for the same settings of depth as XGBoost default values, it'll grow like deeper and sort of more lopsided trees. XGBoost has added the ability to do that in XGBoost. They have something called loss guided tree growth. So there is a lot of like sharing of ideas between the projects. If you go look, I'll give you another example. If you go look in the LightGBM repo right now, you'll see a PR with a title like click-through rate target encodings or something like that. I don't remember what it's called. That's been open since last year. That is adding sort of XGBoost style handling of categorical features to LightGBM. So there's a lot of sharing between the projects, which has been really cool.
That's really cool. Yeah, it's like kind of converging on similar ideas that are really useful, more general. I feel like you've read my notes because you've kind of pre-answered a load of what I thought were really good questions. No, so like it leads me on to, I was going to say, I'll do this one first. I was going to ask, what is the community like behind LightGBM? And do you think enough people get involved, and how would you go about sort of attracting more people to do it or to get involved in this kind of stuff?
Yeah, I'd be happy to talk about that. So LightGBM can be a very intimidating project to work on. When you come to the repo, you're going to find a non-trivial C++ library with a C API. You're going to find code for generating sort of a JVM interface into that with Swig. You're going to find an R package, a Python package, Docker files for building images. You're going to find a bunch of gnarly shell scripts for CI. You're going to find that the build system is CMake for the underlying library, and that the way that the Python package's install works is by using string formatting to put together a CMake command that's then like shelled out with os.system or subprocess or something like that, right? It can be a very intimidating project to work on. So I think that I found that sort of like good first issue types of contributors, people who are saying, hey, I'm just like trying to fix this unused import, writing one unit test, something like that. There have not been as many of those as I've seen in other projects, as I saw in the Dask ecosystem. I really want to work on changing that. I really think that there are ways to work on this project that don't require you to understand all the components or even most of the components, and that do make it easy to work on. But just anecdotally, or I guess not anecdotally, empirically, I haven't seen that many contributions like that. The way the community is structured is kind of like the one you'd expect reading Nadia Agbal's book, Working in the Open. I hope I didn't get that title right, but her book about it's called like The Making of Open Source Software, something like that, where basically we have a small set of core maintainers, and then another small layer of like what she calls active contributors. And these are people who are not officially affiliated with the project, but they have very strong opinions and are very talented and work on mainly like large-ish features. And sometimes those people do become maintainers, which has been interesting. So all that said, how would I characterize the community? We know that a lot of people use LightGBM. We know that LightGBM is popular in data science competitions. We know that LightGBM is popular to sort of like toss into an ensemble with other methods. As far as contributors, I'd say we have like 2 to 4 very active maintainers, another level of like 4 to 5, basically people who have commit rights, but who are not interacting too frequently with the project, maybe like once every 3 months. And then another layer of maybe like 8 to 12 sort of active contributors who pop up every couple months with like, hey, I implemented this big feature. What do you think about it?
Yeah, and it's funny how there's parallels between that and just community in general, and how I see things with the MLOps community. And you see there's probably a good core of people that are very active, and then you have the other ones that jump in occasionally, and then there's a bigger ecosystem of people that are around, and maybe they'll get active sometimes, but only for very sparse occasions. And so it makes complete sense, though, because at the end of the day, an open source project is very much a community-led project. It's not something that you get from the top down. So I want to change gears, though, real fast. And I know that you have had an awesome career building machine learning development cycles, building the infrastructure around it at your different companies that you've been at. You said right now you're at SpotHero. You are passionate about trying to get the most out of data scientists and having the engineers be able to understand the data scientist language and be able to mesh nicely with them. So maybe we could get a bit of background on what you're doing right now at SpotHero, how you've built the platform that the machine learning engineers and the data scientists use, and what learnings you've had along the way.
Yeah, sure. I'd be happy to talk about SpotHero. So to start, I should say there is not a machine learning platform at SpotHero. We're in early days. We're in like design, architecture proposals, argue about which vendors to use stage of that process. And it's been really interesting. So I joined SpotHero a couple months ago, over the summer of this year. So maybe call that like 6 months ago. And SpotHero's had a data engineering team. They have other sort of software engineering teams that build focused applications. And then SpotHero has a data science team with, the target size of that team is like 4 to 5 people. Right now, there are 4 data scientists on that team, and maybe 1 or 2 other people who are not data scientists by title, but who are doing applied machine learning work. They are training, using libraries to train models and like wrapping those models in applications. The process we've been going through recently has been on looking for sort of where we should focus on bringing some technology in place to put like guardrails around the data science development process. And we really we've been starting from a place of model deployment is sort of bespoke Airflow jobs. All sort of like model scoring is batch scoring. So we don't have models deployed as REST APIs. We don't have models deployed as sort of streaming applications triggered by the arrival of data. We have sort of like batch scoring in Airflow, right? It's like it's a great pattern, like it totally works, but very few guardrails around that. Sort of each model has sort of been its own unique thing. So what I tried to do when I started here was just to work with the data science team for a little bit, to start joining their sort of like, I guess like their agile ceremonies, right? To join their like meetings where they demo to each other, to talk through problems with them, to see like what they're working on, what their challenges are. And I think that we have a good path forward. And I'd love to tell you a little bit about that. So I love being in the MLOps community Slack and watching these podcasts and hearing people talk about all of the cool technologies out there for model deployment. I cannot wait until I get to like work with Seldon every day and MLflow and whatever, right? That is not where we're at. That's super not where we're at. Right now, where we're at, the data science team has so much opportunity like to work on problems, and they're limited by the physical resources they have access to try experiments and sort of just like their time, right? And so where we're really focusing for the next year in sort of our, ML platform or whatever you want to call it, is around enabling experimentation. So that means moving model training into something cloud-based where you can burst to larger resources if you need them, where you can attach a GPU if you need it. That means sort of like providing an experiment orchestration service where if you want to run some hyperparameter sweep over 50 different training jobs, right? You can kick those off before you leave for the day and come back in the morning and review the results, right? You don't need to be like sort of managing that in an interactive environment. Those are the places that I think we're focusing first. And my idea there, right, is like, it would be great. I would be so happy if 6 months from now, we had a ton of ideas that we felt were sort of proved out in the lab, like experiments had gone well and we were ready to productionalize, and productionalizing them still sucked. I actually would be really, really happy with that state, because then when we go to the choice of like, what are our paths to production going to be for models? How are we going to deploy them? How are we going to monitor them? We'll have real use cases to say like, okay, it needs to fit these models, right? So that was a very intentional choice to start down that direction. And I'll tell you, that's partially, we all come to jobs with the baggage from previous jobs, right? And it's partially influenced by things I've seen in previous jobs. I can remember seeing like at a previous job, we had super I shouldn't say lockdown. We had this framework that was basically like tons of guardrails for data scientists, and in exchange, you get a really easy path to production. And the models that data scientists were training were they were all classification models, basically, based on tabular business data with time series features, right? And so like we super overfit other infrastructure around the data science team to those types of models, right? Like, for example, we had some sort of like model monitoring stuff set up that was like, I can visualize sort of performance metrics for my models. And then the first time that a model wanted to produce something other than a probability of the majority class, the first time it wanted to produce to be a multi-class model and produce an array of probabilities as its prediction. The first time someone wanted to deploy a time series forecasting model where a prediction was actually an array of timestamps and an array of values, everything kind of not broke, but was like, no, we can't do that. So this is why I really wanted us to focus on enabling the data scientists to sort of prove out more experiments, to prove out more of these ideas, so that hopefully near the end of 2022, we can be talking about model monitoring and deployment and like bringing some more guardrails to that process.
That's brilliant to hear, because just for me personally, very selfish now, but I'm currently going through trying to convert some of the really good maturity models that you get out in the wild. Like Microsoft have one, Google's one's pretty good. There's like AtScale, there's a few of them, right? Trying to convert them to something that applies to origami and what we're trying to do. And I feel that a lot of I think they're valuable tools to have, these kind of maturity models, because sometimes I'll say something and it just goes over the head of everyone, the exec, the product owners, like, because I'm thinking about like a use case that will come up when we start doing monitoring, when we start doing deployment. Like, okay, yeah, what if I want my model to call the API every 15 minutes for 9 months of data, like every day, blah, blah, blah. And that people go, well, why would you want to do that? Da, da, da. Have you any experience with these kind of maturity models, or have you used them? Are any you like, or is that something you think that maybe us as a community, we could sort of converge on and collaborate on a little bit more, maybe?
I'm actually not familiar with the term maturity model.
Okay.
Could you clarify that for me?
Yeah, so essentially, like Microsoft one's quite good, right? And they talk about, so they break up MLOps into, or data science into areas, right? Like governance, exploration, deployment, monitoring, things like that. And then they give you a scale, and it's like 0, like not doing it, and 5, like you're at the forefront of everyone in the world of doing this kind of thing.
I see, sure.
And then it's basically just a metric by where you can measure yourself and what you're doing and like what benefits you get at each stage, kind of thing, really.
Got it. Okay. Yes, that makes sense. I definitely have read things about those. At this point, I have not brought any sort of like formal model like that into SpotHero. My approach has been like to try to say, here are the real problems in front of us, and like, here's sort of an architecture decision record explaining alternatives to solve them, and like, let's pick one and do it. I have actually wanted to be careful about us getting hung up on trying to define how mature our practice is, or like, I feel that exercise, if it doesn't, I feel that exercise can lead to maybe misunderstandings, people feeling like they're being criticized.
No, I get that. So I actually just came into that through being a consultant, and it's even more offensive when you're an external person getting paid, like, to tell people that their stuff's rubbish.
So you mentioned how, and let me see if I can formulate this question correctly, and you can follow me here, because words are hard sometimes. And so putting them together is even harder. And what I am trying to grapple with in my mind is around what you're doing right now, and you're being very patient and looking at all of the bottlenecks as they come, and not trying to see too far ahead, because you want to make sure whatever the bottleneck is right now, you have a really good story around and you can move past that. And you mentioned how you brought some baggage from your last job where it was almost too constrained and there wasn't much of this creativity or the cutting edge being able to happen because of the way that things were set up. And so I'm wondering if you feel that the time to market to get something that is machine learning out there is better to do it slowly and just prove out the value as you're doing now? Or is it better just to get something that is very vanilla out there and have the bumpers on it? Did that make sense? Does that question?
Yes. I think that makes sense. You're talking about the trade-off between speed and confidence in what you're delivering, right? Yeah, totally on board with that. So first I'll say, like, the sort of platform that I talked about from a previous job where we had sort of pretty strict guardrails on data scientists in exchange for a very, very like clear path to production. I don't necessarily feel that limited creativity. I mean, people were able to still do a lot of creative things. It just was like that really like sort of enabled high throughput of producing a particular type of model. And when we took on projects that required other types of models, which by the way was still a minority of the projects that we took on, then that data scientists had come to expect a certain level of support for deploying and monitoring and updating things. And I think we're maybe surprised to find that they had strayed far enough off the path that like they were kind of on their own, you know? Okay, so how am I thinking about this at SpotHero? And I'm going to say this is me, James, saying how I think about this. I can't speak for how other people at SpotHero are thinking about this. You know, my role right now is to make proposals and try to get them adopted. So this is my personal opinion. My personal opinion is that right now we are not a data science consulting company. We're not selling sort of, you know, insights as a service or anything exactly like that, right? SpotHero it's a marketplace, right? It's a consumer facing company. We make money by people booking parking spots, and we get like a little cut out of those transactions, right? And so what that means is people are not necessarily using SpotHero because machine learning is a core part of the product. We are sort of being judicious about where we apply machine learning to make some of our applications better. Because we're in that stage right now, right, where machine learning features are not necessarily a core part of the product, where they're like something that we're working on to enhance the product or even to enhance our internal operations, right? Not every machine learning model we have even ends up directly impacting the product. Some of them impact like how we market to customers or other things like that, right? I've felt that getting more models out faster, like all the way out, like fully sort of where they are, maybe producing customer facing outputs, maybe not, is not in our best interest. We have a small data science team, a small data engineering team, small relative to the amount of data we're collecting and the like sort of opportunity space, right? I don't think that there's pressure right now for us to have like every button that you click in the SpotHero app be powered somewhere down the chain by a machine learning model. That pressure is just not there, right? So I actually have been comfortable with the idea of sort of making sure that like once that we're solving problems sort of one step at a time and sort of like shoring up behind us so that we feel pretty good about a solution to one part of the stack and can move on to the next one. It's kind of like, have you all ever heard of the drill Big Bertha? So Big Bertha is this drill for drilling huge tunnels underneath cities. Okay, it famously got stuck in it's either Seattle or San Francisco a couple of years ago. I don't remember. But what Big Bertha does, and this drill is awesome. What Big Bertha does is as it drills under a city, it actually lays like these slabs of concrete behind itself to shore up the tunnel. It's awesome. That's the way I'm thinking about this at SpotHero, right? Like we're not trying to fly through, like build the tunnel as fast as we can. We're trying to build it in a way that the parts behind us don't fall down as we get further along. Does that make sense?
Totally.
No, definitely. There's a book I was recommending recently that's balancing agility and discipline. That's about it's quite an old one, but I'm kind of currently working my way through. So you've mentioned tools a fair bit. There's a couple of things I want to catch on to, two kind of themes. First one, tools. You've mentioned tools a fair bit. So what like tool out there are you most excited to use, or what do you think's got the biggest potential? What one really kind of you keen to get involved with at SpotHero and think this is going to make a big impact? And then secondly, kind of counter to that, is there, you might not have done this, but is there anything that you've made a conscious decision, actually we're going to code our own despite there being tools out there because they don't match your use case specific enough? So yeah, those two would be really interesting just to hear your point of view.
Sure. Yeah, those are great questions. Is there a tool out there that I'm really excited about? So there's I'm actually really excited about what's happening in the space of packaging models to be sort of not tightly bound to the environment that they were trained in. So I'm excited about Selden Core and about MLflow. I still haven't given up on projects that have become household names like Onyx and PMML and the PFA format. I actually am a really big fan of these model packaging projects. I think that this idea of sort of creating a portable scoring artifact that is decoupled from the environment that where training happened is like really powerful. I'm interested in those, just like personally curious about those. We're not there in our journey at SpotHero yet, right? And this is one of the things that has been something that I'm still learning. The first data science team that I worked on that formally called itself a data science team, that wasn't like I worked on a corporate economics team, for example, right? The first team that like sort of formally called itself data science. At one point we had 70 data scientists, right? That's not the reality at SpotHero. At SpotHero, we have 4. 3 years from now, we might have 5, and that's the right size for us. It's the right size for our business. It's the right size given the problems that we're working on. And so what that has meant is there are places where like it can be okay for a while for us to do things ourselves. Like it can be okay to say we only use Python. Sorry, we don't use R. We don't use Julia. Like we're just machine learning work is Python. Scoring artifacts are pickled scikit-learn API compatible Python objects. And the way that scoring works is in an Airflow pipeline, you read in one of those pickle files from S3 and load it. Like, yes, there's lots of things that can go wrong there. There's lots of like that's limiting in the sense that you can't use things from other languages or some frameworks that like you might have to write a wrapper class to make it scikit-learn compliant, et cetera, et cetera, et cetera. But I felt like that's one of the things where because we have a small team, that's actually a good place for us to say we can take on that complexity because we're not working with like hundreds of models, right? So I'm really excited about all of the projects in the space of packaging models for distribution. But we're not working with those yet today at SpotHero. Did that answer both your questions? I'm not sure.
Yeah, well, so the first one was, tools. No, I think that's really cool. The other one was about, have you made a conscious decision to code your own for anything that is already out there? But maybe you haven't, because that's not always true, I don't think.
Yeah, it's a good question. To code our own for anything that is out there. So we haven't done that yet for anything that's super close to the machine learning space. I can see some places where we might consider it. So I'll give you one example. This is just a proposal. I'm not saying that we're necessarily doing this yet, right? We have Apache Airflow running in our environment. Many companies do that, right? And that, we've given that significant sort of care and feeding, like people, business analysts in the business, other engineers, data scientists are comfortable working in that system. They're comfortable scheduling batch processing. Well, Airflow is all designed around scheduled processing, right? It's designed around the schedule. The schedule is like the core part of Airflow. So Airflow is not ideal in the way that it lives for experiment orchestration, for saying, I want to run 20 training jobs right now, each with slightly different configuration on demand. Airflow is not really made for that, right? It's made for like batch processing. And you can do it. Airflow has something called external triggers, which says basically you use like a HTTP request or a little like one-liner from the Airflow CLI to say, trigger this DAG right now. It also has parameterized runs where you can say like, pass this dictionary of configuration into this run right now. My read of the Airflow documentation and my experience with that system is that using those features is sort of like on the edge of what is supported, right? That it's like not the core use case that they envision. So how am I actually answering your question or just rambling? Yes, I think you are. And let me tell you how. I can see there being a near future, where we say, okay, we've like looked more deeply into some vendors for experiment orchestration. We found that they don't exactly meet our needs. We already have this experience in the company working with Airflow. Let's write our own thing for data scientists that allows us to use Airflow as an experiment orchestration platform that puts some guardrails around it, right? That says, for example, we're going to expect that you're not coming with Python code, but you're coming with a Docker image, and we're going to use the Kubernetes pod operator in Airflow to run your training job, right? Cool. You don't have to choose how your sort of like scoring artifacts produced by training, your metrics, your like any other stuff you need. You don't have to figure out how to store that. Use this little like library that we write, and that's like, we're going to dedicate a bucket in an object store for that. We're going to like, the library is going to decide how those things are versioned against each other, et cetera, et cetera. I could see that being palatable and like a reasonable choice to make at SpotHero in the near future, but not something that I'm saying we're doing
No,
right
very
now.
cool. I completely get it. Yeah.
I think I'll say too, the one other place where I think it is useful for data science teams or like for organizations to be writing their own stuff is around data loading. So, right, like there's like very, very solid tooling, libraries, whatever, for moving data between different systems, right? Like there's a million different ways to write SQL against Redshift and get it into a Pandas data frame, right? Like that's like no problem. I do think that there can be value in having libraries sit between sort of your data stores and your training code, which express data loading in a way that's specific to your company, right? This is something that I think Salesforce did really well with. I can never pronounce it. What's a thing called Transmogrify or whatever, right? Where they had these higher, do you know what I'm talking about? Have you seen that? That's like Salesforce's feature engineering library, right? They had these higher level types that weren't just like, get this data. They were like, this type is a latitude, longitude, elevation point on the surface of the earth. Or this type is like a home address. This type is a whatever it may be, right? I think that there can be value in companies writing those sorts of middleware that let data scientists work with the company's data using like the domains that the company's sort of applications manage, right? So that you're not always just like running raw SQL against the data store, that instead you're saying my model relies on customer data plus purchase data or something with a little bit more sort of like meaning to it. You know what I mean?
So along the lines of your building decisions, I think it's fascinating to look at how you are a 4-person data science team and you're saying 5 people is where we want to be at. In 3 years, we're not trying to triple or quadruple the size of this team. What are some design decisions that you've taken because of that? How different that is than when you were working with 70 data scientists? What are some things that you're actively thinking about in that regard?
Sure. Yeah. So I think that one place where we've acknowledged the fact that the team is going to be single digit team members for the foreseeable future is in sort of our decisions to not put guardrails around certain processes. So for example, I was talking about like having a library for data loading that sort of expresses data in terms of the business's domains, right? We may do that in the future. If we had a data science team of 20 people, I would feel very strongly that 1 or 2 data scientists should just work on that and do that and own evangelizing that library as the access pattern for the team. With 4 data scientists, that's a tough sell to say the data science team should work on that, because that's like cutting into substantial sort of capacity to do exploratory work or other work, right? And with a small enough team, it's like there's a limited, like the small team means that there's a limit to the proliferation of code that gets written that someone else would have to maintain if someone left, right? And so it means like I've been kind of okay for now with people basically writing raw SQL against data stores instead of working in that middle layer, as one example. I think another example where this has come in is in the reverse, which is asking the data science team to meet the rest of the organization where it is in terms of engineering practices. So for example, right, like as we've started designing out how we're going to do a remote development environment, how we're going to do experiment orchestration, like running training jobs and stuff. The data science team, their strong suits are not necessarily like building container images or using sort of like building CI pipelines or stuff like that. But I felt that with a small enough team, it is actually manageable to say, instead of us building around, your maybe like lack of experience with those things, we can do one like 4 to 5 hour synchronous training and just get you enough knowledge of those things to work the way that other engineers in the company work. You know what I mean? With a team of 70 people, I don't know that would have been true. That would have been like a big lift, right? Those are some of the decisions that we've made at SpotHero. I'd be happy to talk more about that if you'd like.
Yeah, one of the things that because I think it's really interesting, and you get a lot of advice out there in the wild about that, like team shapes, roles, and things like that. But there's a huge gap, isn't there, between I've got 100 roles in my data team and I've got 4. And something that always, like, what's the ratio and how does it split? Like, for me, I always lean very heavily on more data engineers, please. Like, let's get the data in a nice state. Because actually, 9 times out of 10, just having tidy data that's easy to do reports with gets you most of the results, yeah? But then when do you get a data scientist? When do you get a machine learning engineer? And how does that ratio change as you get bigger? And then that leads me on to, like, the risk of the unicorn. One person does everything but never actually gets anything done and things like that. Have you experienced much of that?
Yeah, that's an interesting question. We it's yeah, that's a really good question. I think it has been useful for us to have data science and data engineering teams that are similar in size. It has been useful to have a data science team acting as a source of requirements for the data engineering team, helping us to prioritize on which data sources to move to where, et cetera. I think it's also been useful that the practices of data science and data engineering have been sort of like maturing alongside each other at this company, because one running ahead of the other can generate some friction. So, for example, I remember at a previous company, we had a system that was designed by engineers with very little input from the data science team. The system was designed for high-speed ingestion of high-volume time series data, right? And the system was designed sort of without considering data science use cases. Its goal was to maximize throughput, maximize how many records can we get from out there to stored durably per minute, per second, per whatever, right? And what happened at the end was that system was beautiful. Like, could have been a conference talk, probably should have been a conference talk. Like, amazing things were done, but extremely difficult to use for data scientists as a result of some of the decisions that were made, right? For example, like data was indexed by these sort of UUIDs, which is fine in and of itself, that defined an individual time series. No service was provided to map those UUIDs to what they meant in the world. So they were just bytes and UUIDs kind of just hanging out. That is the kind of thing that can happen, right? If like one half of if the data engineering is sort of like just trying to do its own thing without input from the data science team. So I think that it has worked well for us at SpotHero. And again, I've only been here for 6 months, but looking from what I see from previous iterations, that those functions have sort of like evolved together and given each other requirements, helped each other to grow. I think that has resulted in like a pretty good state.
One thing that you mentioned, and it's something that I talk about a bit, it's like this empathy, cross team empathy, right? Like the data scientists understand what it means to check something into Git, or the engineers understand what it means to be a data scientist, and sometimes things get sloppy. Do you have any ideas on how, because for me talking to you, it's obvious that you are like, when I think of a machine learning engineer, I kind of think of you. You're very heavily on the engineering side, and you also know a lot about the data science side. So that is the perfect combination. But how do you help the engineers get a little bit closer to the data scientists, and the data scientists get a little bit closer to the engineers? It seems like with the data scientists, as you mentioned, some kind of synchronous call for 4 or 5 hours just to get the basics down is great. Would you recommend the same thing for the engineering side? Because sometimes when data scientists talk, it can sound like gibberish.
Yeah, for sure. I think that one of the most important roles of the machine learning engineer is to be a translator, is to turn data science requirements into engineering requirements and vice versa. I think that's one of the reasons, one of the things that I ask candidates who are applying to machine learning engineers roles with us is I ask them, like, what would you say if someone told you, we already have a DevOps team and we already have data engineers and data scientists. Why do we need machine learning engineers? Like, what's the point? We already have all these other people. I think that translation part is really, really important, that you're able to sort of like, for example, if you ask a data science team, hey, do you need another 3 months of history for this data set? They're not going to say no, right? They're going to say, yeah. can we have 5 months or 8 months, or like can we have all of it, please? Right. It's important to have that translator in the middle that can say like, okay, like let's talk a little bit about where the responsibilities are here. Probably the data science team's responsibility for like showing the improvement in their confidence of their results, or in the actual like predictive power of their results from more data, et cetera, right? Another way that we can sort of build empathy and work together is in the way that we've designed the definition of our teams. So at SpotHero, so machine learning engineering is a part of data engineering at SpotHero. And on data engineering at SpotHero, we are not the ETL team. We are not the like come up with an idea and then huck a design doc over to us and we implement something bespoke for you team. That's like not how it works. Of course we have some of those. We all have some of those, but the way that we've sort of set up the interface with the rest of the business, with business analysts, with data scientists, is that we are an enablement team. Our job is to build self-service technologies, whether that's libraries, services, infrastructure, that say, here's a contract. If you meet the contract, we are responsible for the service doing the things that it promises, given that you came with this contract, right? I think that is another way that we sort of build empathy for each other's workflows, because what inevitably happens is data scientists will come up against that contract and say, well, I need to do this one other thing. Like, how would I do this other thing? And we just sort of naturally end up having those conversations where we understand like, oh, I never considered that you need to do that other thing, but that kind of makes sense to me, you know? So I think that helps. And I also think, it's to your point about synchronous meetings, that's one of the advantages we have as a small team. Even if you think of like bigger than just team, our sort of like organizational unit of like analysts, data scientists, data engineers, and machine learning engineer, that's like 20 people total, right? So there's enough that like we actually do have, I think once a month or maybe once every other week, a joint stand-up with everyone. And people really do say like, here's what I'm working on. Here's what I need help from this other team. So that is one of the benefits we have of being a smaller organization.
Lots and lots of parallels to some of the stuff I've been doing recently. It's quite interesting actually to hear it from you, James. That's really cool. So I let you pick then. I always like to ask people because it's quite awkward sometimes, but either like proudest technical accomplishment or like biggest frustration sort of thing that you've maybe less proud of and lessons learned. I'll let you pick.
Yeah. Interesting. Wow, that's a tough one. See, and if I knew this was going to be a job interview, okay, I would have prepped for that.
Exactly. What is the typical thing? Like, oh, my worst quality is that I work too hard. I can't help it.
Yeah, that's a really interesting one. I think that the thing I'm most proud of in my career so far is, how do I explain this? At a previous job, so I mentioned this sort of like, I mentioned earlier, this system we had at a previous job where a lot of like valuable data was being ingested and then not really usable for data scientists, right? That was in sort of an earlier iteration of a previous company's platform, you might call it, right? And in a later iteration, I was sort of like the data science team's representative in the next version of that platform. Like we got this thing that I think is very rare in tech. We got this sort of opportunity to rebuild from scratch within the same company, right? I'm really proud of the result of that work generically, not necessarily in any specific piece of software, but we came out of that sort of first round of that work with engineers understanding what it meant to power machine learning models and data scientists understanding why certain engineering decisions were made, teams talking to each other. I mean, I would walk around the office and I'm not taking credit for all of this, by the way, but I was happy to be a part of it, to think back to like, you know, a time in my career where I had seen data science team and engineering teams like not talk to each other at all. Right? Data scientists ask for help in Slack channel for like team A, and they say, oh, that's kind of a team B thing. Team B tells them like, it's kind of a team C thing, and like horrible, right? I'm really proud of the work that we did at that previous company where we were sort of all building the same things and like having these very, very interesting conversations about trade-offs between what data scientists wanted to be possible and what engineers felt comfortable supporting. Is that too vague?
I absolutely love the fact that MLOps podcast, I asked a kind of a technical question. I love that you've come back with a very people-focused answer. I think that's so important. And there's so many people out there that they tackle everything tech first, when actually it's only a small part really of the real challenge, which is getting people aligned and on board and getting the right stuff done and things like that. So no, look, thanks very much. Really cool.
Sure.
Yeah, brilliant, man. This has been so good talking to you. I know we've kept you over on time. I could have talked to you for another hour at least. I really appreciate this. We're going to have you back on the podcast, and maybe in 6 months, we'll get an update on where you're at and how it's been at SpotHero. For anyone out there listening, are you guys hiring? How can they follow you? Give us what's up.
Yeah, totally. We are hiring machine learning engineers and data engineers right now.
Nice.
But we're looking for people based in Toronto or Chicago. You can find me on Twitter. It's just twitter.com/_James Lamb. James Lamb, fairly common name, so I had to add the underscore at the beginning. And you can also find me. You can also find me in the MLOps community Slack, and message me anytime. Happy to talk.
There we go. Yes, I really appreciate you being in the Slack. I appreciate your insights, and this conversation was awesome, man. I really cannot thank you enough. So, Adam, of course, I can't thank you enough either. This
Pleasure,
is awesome that you've come to the other side. You're starting to, because we first interviewed Adam back in the day, and then now he's just, I conned
Like
him
a bad
into
smell,
helping me out. Yeah. So we'll see you all later. And thank you, everybody. If you're still listening, of course, like and subscribe and all that stuff. You can get bell notifications now on Spotify. But I looked at the analytics, and it turns out that most people listen to this podcast on Apple Podcasts. So I don't know if you can get those bell notifications, but I know you can subscribe and you can leave a review. So if you feel so inclined and you're inspired, the spirit moves you, leave us a review. We'll see you all later.